All right, here's more on the sine, cosine, and tangent, more of a applications, problem solving, couple different approaches to it. Again, it's taking you through this a little bit. The last assignment that you did was really focused on tangent. I don't know if there was any sine and cosine. That's okay. Obviously, now we're going to move you into sine and cosine. Don't like my right triangle, so we will restart that. Okay, so we need to be pretty decent at, all right, if I'm going to measure that angle right there at 23 degrees and say that I am given a side length, I don't know, we'll start off with that one. We need to be able to say, hey, I'm going to find both x and y in this type of situation. And again, the identification process to me is the big deal, that if we say, okay, I'm going to relate this to the 23 degree angle. So let's see, 15 is across from the 90 degree angle. That makes it the hypotenuse. This is across from the 23, so the angle that I'm working with, that makes it the opposite. That makes this the adjacent. So we're going to have two different setups to find each x and y. So let's deal with x first, with x as the opposite. So your decision, remember where we came from last time, was this SOHCAHTOA idea. Sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, tangent's opposite over adjacent. You know, and if you were in class, you would have got the bad jokes about what do you do when you drop a block of concrete on your toe. Well, you SOHCAHTOA. Or Sacagawea's sister was the real brains of the outfit, and that was SOHCAHTOA. Whatever, something that lets you forget it or remember it, that sine is opposite hypotenuse, cosine's adjacent hypotenuse, tangent's opposite adjacent. Okay? So as we go through here, and we want to deal with and say, well, I want to find x, which is the opposite, and I know 15, which is the hypotenuse, which trig function relates opposite and hypotenuse together. So we look, well, right away we run into sine. Sine is opposite over hypotenuse. So our setup, the sine of 23 degrees is x over 15, because x is the opposite, 15 is the hypotenuse. So as we approach that, now we got to solve for x, obviously. Well, x is the unknown, it's in the numerator, so we can isolate that by simply multiplying both sides by 15. So 15 times the sine of 23 is going to turn out to be x. Okay, so I'm going to have to go find myself a calculator to make that work. So let's see here, we'll just go out here and I'm just going to Google scientific calculator. Scientific calculator, I'm pretty sure Desmos has one for us, or actually there's one right here that we can work with, and I can simply type in 15 sine of 23 degrees, and you can see it's all right there in place. Now again, notice radian degree, and on this, I don't know if you can see this or not, but RAD is highlighted. Radians is another type of angle measurement. We are working strictly in degrees, so I'm going to click that, and so my degrees is now darker, and that means this is 23 degrees and not 23 radians. It makes a huge difference. Radians you'll get into in Algebra 2 when you start dealing with trig. So go ahead and hit equals, so 5.86, so my x value, 5.86 equals x. Okay, and I really don't care if you round it to the nearest tenth or whatever. I think actually most of the ones that I put on the assignment that's on Schoology are round to the nearest tenth. So if that was the case, we would come back and say that's about 5.9. Okay, turn our attentions to y. So y, as it relates to 23 degrees, is the adjacent. Okay. And I still know the 15 is the hypotenuse, so I'm looking for adjacent and hypotenuse to get put together. Well, there's adjacent hypotenuse. It's connected by the cosine function. So my setup here is going to turn into the cosine of 23 degrees equals y over 15. And once again, we see the unknown is in the numerator, so if we go to isolate y, we simply multiply both sides by 15. So 15 multiplied by the cosine of 23 degrees is y. And so, let me go back to my graphing calculator. So I'm going to see there's going to be a clear here. So 15 cosine 23 degrees equals, looks like 13.80 or 13.8. So it looks like y is going to be about 13.8 units. Okay. Now, just a couple things. Let's see here. 23 degrees. 23 degrees isn't a very big angle, and so it creates a 5.9 across from it. This angle, who's got to be complementary with 23, 67. This side should be significantly larger than that, and it does in fact turn out to be 13.8. So if you're really kind of thinking about this, and you look back at your answers and you make sure, hey, do those all fit? Do they all work? Is the smallest angle giving me the smallest side? Is the medium angle giving me the medium side? And is the 90 always creating the longest side across from it, depending on what it is that they're asking for you? So, you know, put a little bit of reason into your angles, okay? We can start throwing situations into here, like, hey, I've got this tower, and I know that out here, 200 feet, I need to stake a cable to determine or to support my tower here. I got myself a cool radio tower going on here, okay? And I need to stretch a cable that goes to the top of that as a support. Okay, so well, how long does that cable need to be? That would obviously be a question that would be needed to be filled out or completed before you could order the cable. So, and then they noticed that, well, the angle of elevation, so angle of elevation is essentially if you went from a horizontal and elevated yourself upward, what is the angle in there that tilts as you look from horizontal to upward? So my angle of elevation is going to be this, because this is my horizontal, okay, and so it's elevating up there. And so we could say a surveyor measures this angle of elevation. Let's say that it comes out at 35 degrees. Now you've got two things that you could calculate for me here. You could get the length of this cable here. You could also determine the height of the tower. And I say we'll do both, but I'm going to call that C right now as the cable. I'm also going to assume that if I drop that straight down and I measure 200 from the middle, that there's my right angle. So I do have the right angle, so I did fulfill my need to be able to apply trig. So let's find C. So we're going to ask ourselves, okay, how does 200 relate to the angle that I measured, which is 35? Well, here's the 90. That makes that the hypotenuse. Well, I'll just note that now. Okay, so that's the longest one. Here's the 35. This side length would be opposite of 35, which means 200 must be the adjacent. Okay, so that's adjacent. So once again, let's see here. TOA setup. So let's just see what we got. We got adjacent and hypotenuse. Boom, adjacent hypotenuse. So that's going to be the cosine function. So I'm setting up cosine. 35 degrees is the adjacent, which is 200 over C. Now I set you up a little differently here because we're looking for the hypotenuse. The unknown is in the denominator. That changes our approach. If we want to isolate C, one of the things I think I talked to you about is if our unknown's in the denominator, in the process of isolating, what will happen is C is going to end up over here and cosine 35 is going to end up there. And the math, the algebra of that is multiply both sides by C. So now your C is over there and it's not there anymore. Divide both sides by cosine 35, so cosine 35 ends up in the denominator there. I would really just appreciate it if you just said, oh, unknown in the denominator, flip-flop these. C is 200 divided by the cosine of 35 degrees. And so now I need to go back to my scientific calculator. So sorry, I'm gonna have to go back. 200 divided by, so I'm gonna go 200 divided by the cosine of 35 equals 244.15, I'm gonna go 244.2. Okay, so that means that C is 244.2. So that cable is gonna turn out to be 244.2 feet long. Okay, let's throw H in here. H is the height. Okay, well, looking at H, how it relates to 35, it's the opposite. And I'm gonna, because this is a rounded value, I could definitely use it, but if I want to be super accurate, let's use the given value. I could certainly set this up as opposite, and now I know my hypotenuse and use the sine function, right? Opposite hypotenuse. But because that 200 is a set known factor, and the opposite is not, I'm gonna say, well, what relates opposite and adjacent? Well, there's the tangent function. So tangent function, let's scroll this down a little bit. So now I'm gonna go the tangent of 35 degrees equals the opposite, which is 8, divided by the adjacent, which is 200. Okay, well, I'm back to having the unknown in the numerator. We like that. I just multiply both sides by 200. So 200 tangent 35 is H. All right, back to the calculator. 200 tangent 35, so 140.0, perfect. Okay, so we're looking at H being about 140.0, 140.0. Hey, now let's check the reasonableness. 35 degrees, that means that's going to be, I believe, 55 degrees. 200 to 140, perfect. Longest side 244, perfect. Everything kind of fits and everything looks really good. Okay, so you're going to see that basically where you're going to just give in some triangles and say find this side. And so the identification process is going to be the deal. Which trig function are you going to use? Okay. Oh, Mr. Stanikar is making a guest appearance. So like anything to say to honors geometry, who you're looking forward to seeing in world history?
Not at the moment. Talk to him later.
Okay. Do you mind if I continue?
No, go for it. In fact, I'll be.
No, for you. I can teach you how to find the missing angle of a right triangle when you know the two sides.
I will look forward to that later off camera.
Okay. So there goes Mr. Stanikar again. Mr. Stanikar had his backpack on, almost like he was leaving. So anyway, the last thing I want to deal with that you're going to run into is you might see something like this. Hey, I'm going to call that 10, and maybe that's 22. And they're going to ask you to find angle A. So now we don't know the angles. All we know is we've got a 90 degree. So let's make some adjustments. 10 lists out as the opposite. 22 lists out at the hypotenuse. So again, we reference our SOHCAHTOA. Okay. So our SOHCAHTOA setup. Which trig function? Well, opposite hypotenuse is sine. And I'm looking for angle A. So I'm going to figure out angle A is what I'm going for. So now the sine of angle A is going to equal 10 over 22. But I need to figure out angle A, and to do that we're going to do what's called an inverse operation. Basically we're going to undo the sine. Now here's how this works. This means that angle A is going to be the sine, and you're going to see a little -1. That references the inverse. The inverse is always going to say, hey, I knew these sines, or I knew these side lengths, provide for me the angle. Okay? So now I know the side lengths, 10 and 22. I'm going to do the sine inverse of 10 over 22. And again, the angle was unknown, but the sides were known, so I'm using an inverse sine. Well, let's check out our calculator. And this particular one happens to have a button that says inverse. You're probably going to spend some time on your calculator trying to figure out, okay, where are my inverse functions? I think if I hit inverse, and I doubt you can see it, But right now, my sine turned to sine with a little -1. Cosine turned to cosine with a -1, and so on and so forth. Well, if I hit sine inverse, and now really weird, on the calculator it's called arcsine, and it took me until almost college was over to figure out that the arcsine and the sine inverse are the exact same thing. Okay? In calculus, they really like it as the arcsine. So understand those are the same things. So when you see, when I write it as, let me go back to this, when I write it as the sine inverse of 10 over 22, it could very well also be the arc sine of 10 over 22. There's a lot of reasons why, there's really one big reason why they like this, especially in calculus. Calculus has a lot of rules that deal with the exponents, and a lot of people confuse that with being an exponent. It's not. It's notation for inverse function, which is something you're going to pick up in Algebra 2 and pre-calculus, what exactly an inverse function is. But, so to clarify it, many of your calculus books have now gone to arcsine. So, anyway, going back to here, I would like to do the arcsine of 10 divided by 22. I'm still in degrees mode, so sine inverse or arcsine should push back at me an angle. So when I hit equal, 27.0, okay? So what that's telling me is essentially that's 27 degrees. This is coming out to be 27.0 degrees. Okay. Now, obviously, if that's 27, I could figure that out as well. 90 minus that, and then will give me what, 67 degrees, or 63 degrees, sorry. Okay, all right, I think you need to see that one more time before we call this a day. Let's see, I'm gonna throw a 50, oh no, wait, I'm not gonna throw the angle at you, because that's what we're trying to find. Let's go with 12 and 17 right there. And I'm gonna use a Greek symbol this time for the angle. I'm gonna use, that's called theta. So that's my angle theta. Sometimes you can use capital letters. A lot of times they'll throw a Greek symbol in there. Sometimes it's theta, alpha, beta, whatever. Theta is going to be our pretty common one. So we want to figure out what theta is. So as we look at this, let's see. Well, 17 is across from that. So 17 is my hypotenuse. 12 is next to it. That makes 12 my adjacent. So the trig function that relates adjacent and hypotenuse, okay, SOHCAHTOA, that's cosine. So the cosine of theta is adjacent, which is 12, over 17, okay, which now means, okay, I need the angle, so that means theta is the cosine inverse of 12 over 17. Okay, so we go back to our calculator. Inverse cosine, which there's our arc cosine, 12 divided by 17 equals 45.09 or 45.1 degrees. So come back to this. So theta is about 45.1 degrees. Okay, you know, while I'm at it, hey, there's alpha, which that'd be 90 minus that, 44.9. Let's see if that's what we actually get. So now if we deal with alpha, 12 is no longer the adjacent, 12 is the opposite. Now 17 stays as the hypotenuse, so the sine of alpha is 12/17, so alpha is the sine inverse of 12 over 17. So let's go to this, inverse sine 12 divided by 17, 44.90, a good deal, exactly what we were expecting. 44.9 degrees, which happens to be the complement. It all works. Notice the switch where this was the adjacent if we dealt with theta, but it's the opposite if we dealt with alpha. Okay, that should get you through the Schoology assignment that is currently up. All right.